Disproportionation. This video shows how to balance disproportionation reactions. In this reaction, what is unusual is that there's only one reactant, bromine, which forms two products, bromate ion and bromide ion. Some of the bromine atoms undergo an oxidation and some undergo a reduction. When the same reactant is both oxidized and reduced, that's called a disproportionation. I'm using a procedure here called balancing by the oxidation number method, which I assume you are familiar with. If not, a more detailed video is given in the link below. The oxidation state of bromine here is 0 because it's in its elemental state. Here the bromine is 5+, or +5, either way is fine. How do we obtain this? There are 3 oxygen atoms, each one with a valence of -2, so 2 times 3 is 6-. Now bromine needs to have an oxidation number so that when added to 6- it gives 1- on the bromate ion, and this occurs if bromate is 5+. The oxidation state of the bromide ion is just its charge of -1. Those bromine atoms whose oxidation state increased from 0 to 5+ underwent oxidation, and those whose oxidation state was reduced from 0 to 1- underwent reduction. Now let's write both half reactions out, oxidation, reduction, and the first thing to do in the oxidation is balance the bromine atoms by adding 2. The total oxidation number for Br2 is still 0, but now for these 2 bromines it is 10+, and that comes from 5+ times 2. A total of 10 electrons must have been lost in this oxidation, so we show 10 electrons here as products. In the reduction reaction, again, we must first balance the bromine atoms, so we'll put a 2 here. Bromine's oxidation state is 0 again. The total oxidation state for the 2 bromide ions is now 2-, which means that 2 electrons must have been gained in the reduction. Before adding the half reactions, we must multiply the reduction by 5 so that the 10 electrons in each half reaction will add up to 0 in the final equation. So now we add them, and here is the reaction. The main element, bromine, is balanced with 12 bromines on each side. But notice that there is a total of 6 oxygen atoms on the right side and none on the left. Remember that we can balance oxygen by adding water. There are 6 oxygen atoms on the right, so we'll add 6 molecules of water on the left. That balances the oxygens, but it introduces 12 hydrogen atoms on the left. Remember that hydrogen can be balanced by adding hydrogen ion, so we add 12H+ on the right. The equation is now balanced, but notice how the coefficients are all even numbers and can be simplified. We should do this by dividing by 2. This is our final balanced equation. Here are 2 questions for practice. You could stop here and try them and then come back to check your answers. I'll show the answer to number 1 first. In case you had trouble, just check if the original oxidation states are correct. Here's the answer for number 2. And again, here are the initial oxidation states. This ends the lesson on balancing disproportionation reactions.